we'll talk about now our first colligative property. And the first colligative property we're going to look at is based on the vapor pressure of a solution. And Raoult's law says that the vapor pressure of a solution of a non-volatile solute is equal to the mole fraction of the solvent times the vapor pressure of the pure solvent. So the pressure of the solution is the mole fraction of the solvent times P0, the pressure of the pure solvent. Now, when you look at this, you notice there is nothing in this equation about the solute. I have the mole fraction of the solvent. So that tells us it's how much solvent is there at the surface is affecting the pressure. It doesn't matter what the particles are. So we think about this. Okay, this is pretty straightforward algebra. I have three variables. I know two of them. I can solve for the missing variable. Now, the biggest problem that my students have with these is that when they start reading these, they get all freaked out because there's chemical names in there of organic compounds that we are not familiar with from Chem 111 or Intro. That's okay. Just read the problem. If it says something like dibutyl phthalate, comma, a non-volatile solute, comma, then you know that's the non-volatile thing and it doesn't matter, right? Another key is if it says octane has a pressure of this, you know that if it has a vapor pressure, it's the solvent. So things with vapor pressure are solvent. Things without the vapor pressure are the non-volatile solute, even if you don't recognize the name. So don't get all freaked by that. Okay, dibutyl phthalate, we'll call it DBP, is a plasticizer with a molar mass of 278 grams per mole. Octane is a hydrocarbon solvent with a I said molecular weight and molar mass, using them interchangeably, 114 grams per mole. Vapor pressure at 10.5 torr, 20 degrees. What's the vapor pressure of a solution made from 20 grams of dibutyl phthalate and 50 grams of octane at 20 degrees? So you look at this and you say, okay, what is the vapor pressure? I know that the pressure of the solution is equal to the mole fraction of the octane, the solvent, times the pressure of pure octane. So that's the new stuff for Raoult's law. So now what we have to do is think about, how do I get the information I need? I read the problem and the information on the pressure of the octane has been provided to me. But the other stuff, the mole fraction, I'm going to have to calculate. So we start off finding the mole fraction of the octane. And when I look at this, I know that I have 20.0 grams of dibutyl phthalate. Now, I put the molar masses in this problem just to speed things up because I know you all know how to calculate a molar mass at this point in time, okay? So I know that 1 mole of dibutyl phthalate has a mass of 278 grams. So I have in my sample 0.0719 moles of dibutyl phthalate. Now let's look at what else is in my sample. 50 grams of octane. And again, I know that 1 mole of octane has a mass of 114 grams. So I have 0.439 moles of octane. Now we go back to what we did at the beginning of this chapter, trying to figure out how to find a mole fraction. The mole fraction of octane is equal to the moles of octane divided by the total moles. So the mole fraction is equal to 0.439 moles of octane divided by the total, 0.439 plus 0.0719. So the mole fraction of octane is equal to 0.439 moles divided by 0.511 moles is equal to 0.859. That's my mole fraction. Now I can use the mole fraction with Raoult's law. I know that my pressure of my solution is equal to the mole fraction of octane times the pressure of pure octane. So that is 0.859 times my pressure of pure material, 10.5 torr. So the pressure of my solution is equal to 9.02 torr. Now, I ask myself, does that seem like a reasonable answer? Well, I know that the solution's pressure is going to be lower, it's going down, and I know that it was 10.5 to start, so yeah, 9% it went down, that seems like a reasonable answer. If I came up with 14, I'd think something was wrong because it was higher. So that's probably the easiest problem of this type that you would see, where you're given information, I have so many grams of this and so many grams of that, figure out the pressure. That'd be the easiest. Now let's look at a medium sort of one. What's the vapor pressure of a 32% aqueous solution of ethylene glycol? The vapor pressure of water at 90 degrees is 525.8 millimeters of mercury. Okay, when you read this one, it's an aqueous solution, so that means water is the solvent, so it's water's mole fraction we're interested in. So we're going to convert the percent information into mole fraction. So when I look at this, I know that I have 32%. So it means I have 32 grams of ethylene glycol for every 100 grams of solution. Now, I'm not interested in the solution, I'm interested in the solvent. So it means that I have 32 grams of ethylene glycol, and if I have 100 grams of solution and 32 grams of ethylene glycol, I have then 68 grams of water. I just subtracted the mass of the ethylene glycol from the mass of solution. So now I know how much of each component I have, so I can convert to mole fraction. So in my sample, my 32 grams of ethylene glycol, I'll change that into moles. 1 mole of ethylene glycol is 62.07 grams. So I have 0.516 moles of ethylene glycol. Now I'll do the same conversion for the water. I have 68 grams of water. I know from my periodic chart that 1 mole of water is 18.0152 grams. So I have 3.77 moles of water. Now I want to find the mole fraction. If I know the moles of each, I can calculate mole fraction. The mole fraction of water is equal to the moles of water, 3.77, divided by the total, 3.77 plus 0.516 moles. So the mole fraction of water is 3.77 moles divided by 4.29 moles total, and that is equal to 0.880. Now, I know the mole fraction of my solvent. I can work with Raoult's law. Pressure of my solution is equal to the mole fraction of my solvent, 0.880 mole fraction, times the pressure of pure water, 525.8 millimeters of mercury. Now in the first example we used torr, now we're using millimeters of mercury. You can use any appropriate unit for pressure. Okay, any unit for pressure is fine. So the pressure of my solution is equal to 462 millimeters of mercury. So two different problems, one easier, one mediumer, right? One medium difficulty. We'll look at some really hard ones after you practice the next one. So go ahead, go up to the board with your groups and try this next one. Okay, that's the one for you. For those of you listening to the video, I'm going to put the solution up here now. For those of you listening to the video, we have 4.5 grams of sugar. We change that into 0.013 moles. 95.5 grams of water is 5.3 moles. Then we calculate the mole fraction and multiply by the pressure of the pure material.